clearly audible? Please let me know in the chat. There's some latency between when I start talking and when it's audible to the audience, so that's gonna be there. Let's wait for a few more people to show up, and then we can get into the Docker. Docker is interesting, isn't it? I am very quiet. That's because the volume is low. How about now? Is it too loud now? What about now? Yeah, I think I reduced my volume a bit. Okay, a bit more, I guess. All right, let's go with that. Awesome. So let's wait a minute more for more people to show up. Unfortunately, we don't have free pizza today, but we have some free information here on Docker. So hope that makes up. The popping noise? Huh. What kind of popping noise? That might be my keyboard actually when I'm trying to type something. That's why I think I turned down the volume in the first place. Oops. Yeah, I have a terrible audio setup here. Oh. Is that still happening? This is quite literally my first time. Happening again? Oh, wow, that's bad. I don't seem to have the best audio setup here. Let me see. Oh, okay. I So it's not a mic issue. I think as long as I can sit very still, it won't happen. I think it's capturing a lot of noises as I move. Just funny. Huh. Yeah, I don't know how exactly to fix this issue here. Wait, let me try something. Okay, hoping that this works slightly better than last time. Okay. Yeah, I don't think there's that unwanted feedback this time. So it's just whenever I type something or I use my mouse, it will register some of that audio now. So let's get started. If you haven't already, join the ACM Slack at acmcincy.slack.com.org. I don't exactly remember. And we have proposed an amendment to the ACM bylaws. So the chat will be live all the time. So if you have any questions, just pop them in the chat. After every, I'll I'll be looking at the chat every now and then and answering any questions. So, Docker. I'm here today to talk about Docker. No surprise. A bit about me. I'm a second year IT student. I work as a software developer at the IT Solutions Center, and I'm the conferences and education chair here at ACM. There's some plugs there to my LinkedIn, GitHub, Medium blog, and you can chat me in the ACM Slack anytime. So here's a rough outline. Wait. Yeah, here's a rough outline of my talk today. I will talk about containers first because Docker is a container management tool. So we need to understand what containers are before diving into Docker. And then I have a short demo using Docker, the very basics. And then I'll talk about why people are using Docker, what advantages it offers us, and then another quick demo that shows some of those advantages. And that's it. Before we really get into it, I'd quickly like to tell you all that today is Docker's birthday. On this day 7 years ago, Docker was first shared with the world at a Python conference as a 5-minute lightning talk. And today it's one of the most used DevOps tools out there. So let's get some happy birthdays for Docker. So, what is Docker? These are some headlines from Docker's official website. Debug your app, not your environment, and securely build and share any application anywhere. These actually say a lot, but they're kind of cryptic at first glance, so let's look into containers first. So containers are termed as a standardized unit of software. And we'll get to what exactly that means in a second. The "it works on my machine" syndrome is real, and it happens when you run some code and it works, but when you give that code to someone else or run that code in some other machine and it doesn't work. Now, there's a lot of reasons why that happens. Maybe there's some on a Linux server somewhere and it failed. So there's a multitude of reasons for that. So containers are an abstraction for your code or for your application and the environment that it runs on. A container will host your code and all the required dependencies and create a small virtual environment for your application. You can run anything you want inside a container, and that's why it's called a standardized unit of software. Containers are very comparable to virtual machines because containers basically are virtual environments, but they are much more faster and a lot more lightweight than virtual machines. For the thing about virtual machines is, for creating virtual machines, your machine or your on that emulated hardware. Containers are pretty lightweight because containers only require abstraction of some high-level operating system level things, libraries and binaries, and everything under that, like the kernel, the hardware, everything is shared. And that's why it's a standardized unit of software. So let's compare it more to virtual machines. This is a pretty good comparison that's found on pretty much every tutorial, every article. You can replace Docker here for any other container management tool, and it's pretty much the same thing. Docker runs on top of your operating system, and it hosts containers. You can run your app inside those containers, like I mentioned before. Now, if you go for virtual machines, you have to load entire operating systems on your infrastructure, and you have to use some sort of hypervisor that emulates the hardware that those operating systems run on, and then you load your application inside your virtual machine, your guest operating system, and you can see it right here how much more space the operating systems take instead of the containers. At virtual machines usually take up space in gigabytes, so it's like 5-6 gigabytes something. And containers are pretty lightweight. I think at one point I had about 20 containers running on my Mac, and everything was running very smooth. I couldn't even notice it. So I think this typical size of containers are in like 500, 600 MBs, and there are some other types of containers that are even more lightweight. So that's something for another talk. But in general, containers are way more lightweight than virtual machines. So let's get into Docker now. Docker is, like I said, a container management tool. What that means is that it lets you create and run containers anywhere, and it helps you deploy those containers in remote environments. Docker also lets you package your application as a container image. Now, these images are pretty much like disk images for operating systems or any software that you can buy at stores. These images are used to spin up a container, and the image will load whatever you want, whatever tools, environments you want inside those containers. Docker can also create a virtual network. So if you have multiple containers, like I just said, I had 20 containers running in my Mac. So Docker can help you create a virtual network where all those containers live and they can talk to each other. This is pretty helpful for deploying distributed architecture such as microservices. And Docker has a lot more features than this, but I hope this can get you at least a bit more interested in Docker without being overwhelmed by its giant ecosystem, because that's what happened to me when I started out with Docker. Demo time. Yay. Okay. Let's see if we can get this working. May the demo gods be with me. Awesome. So here I have a pretty simple Node.js application. It has a tiny server, and it has a tiny front end that's written in Vue. We don't need to care about that. So let's get rid of this. Let's get in here, see if we're in the right folder. Yeah, so we have our JavaScript files, our index.html, package JSON, server.js, site CSS. Okay, so let's try running this and see what happens. Magic happens on port 8080. It's actually 80, but anyways. So let's go to localhost, and there it is. There's this application. It's a pretty simple bulletin board application. You can add events here. Docker intro session. Yeah, Vue.js, like the hipsters. Summit. Who remembers Summit? And there it is. We can add events, fetch events from backend, delete them, all that fun stuff. So yeah, that's pretty simple application. Here's some logging, doesn't really matter, and we shut it down. Oh, no. Yeah, I think this is some logging that the application does. So now we shut it down, and now the application doesn't exist anymore. Okay, so this was the application that we were running, right? Now let's see if we can run this application in a Docker container. So the first thing we need for Docker is a Docker file. Now this is how we create Docker images from our applications. The first thing that you see here is from Node 12. So there are a lot of images that already exist out there that have all of the, like, a lot of tools and ecosystems that you want to run in. So this is an image that has Node.js already installed in it. And pretty sure that image has, that image from another image that has Linux of some kind. I'm not sure if I'm making a lot of sense here, but basically what this does is that it downloads another Docker image that has Node installed, version 12. We don't, yeah, let's keep that in there. So this installs a Docker image from the Docker Hub, which we'll see pretty soon, and it uses that image as a base image for what we are building now. The next thing here is that we can go to some sort of directory where we want our app to be. Now this image is some sort of Linux. We don't know which one because we don't need to know right now. So we navigate to this folder. Usually there will be some kind of, a lot of people usually put their applications in OPT apps. So let's change this actually bulletin. So inside our container, it's running some sort of Linux, and we go to this directory /opt/apps/node bulletin. You can have any directory here you want. this is just for semantic purposes. Okay, now this is where more of the magic happens. Okay. Now this copies files from your host machine to the Docker container. So you know dot means the current directory, right? So the directory that Docker file is in, we have all these folders that have JavaScript files. And we have the backend, we have the fonts, we have the app.js, we have index.html, we have package.json, we have server.js. So these are the files that we need to run our application. So the copy command takes everything from the current directory, which is all of these, and puts them inside the Docker container in the current directory, which is this. So it's kind of hard to explain, but it's more like copying all the folders from copying all the files in. The dependencies are defined here in the package.json file. I'm using Bootstrap, EJS, Express, Morgan, and all those fun things. npm install will install all of those dependencies inside our Docker container. Now, this is the command that I just used to run my application, npm start. So this tells the image or the container to run this command when we spin up the container. And we'll see this in action pretty soon. And since the Docker container is like a virtual environment, it's kind of like a sandbox or virtual machine, if you will, we need to expose a port from it outside so that anything outside the Docker container can talk to your app in there. So in our server.js, we are listening at port 80. So we'll need to expose the port 80 outside the container. Let's make some few changes here too. And here. Let's add a callback here. And magic happens on port 80, not 8080. So now as soon as our app starts up, it'll output this message in the standard output, and it'll say that, hey, this is the port on which our application is running. Awesome. Difference between run and CMD. The difference between run and CMD is that run runs this command on build time. So right now when I go into Docker and type docker build, it will run all these commands. What CMD does is it runs this command on runtime. So I'll show that pretty soon. So let's save this. And now we don't need this. We don't need this. Clear. Now let's see where we are. Yeah, we have all these files and folders in the current directory. Now all we need to do is, first let's see which version of Docker we're running. Hey, there's Docker. So all we need to do is docker build and dot for current directory. That's it. That's how easy it is to package your application as a Docker image. Now for the sake of other developers, or maybe myself in the future, I'm going to give it a tag. Now this is a tag which is basically a name for the image. So I'll call this node bulletin. You can call it anything you want. So here's the command that I'll use to build my application, or build the application as a Docker image. Now this is all the steps that we defined. I'm sorry about that. Yeah, these are the steps that we defined in our Docker file. Step 1 of 6. Okay, there it is. It built and it tagged as node bulletin. So step 1 from node 12. So it usually takes some time installing this image from Docker Hub, but I already had that image installed, so it was pretty quick. Then it switched into this directory. It copied all the files. It ran npm install, and this is the output that you usually get from any npm install. CMD npm start. Now that's an entry point which we'll look at later. Expose port 80, yeah, done. And there's our image. Now if I type docker images, I can see what images I have on my machine right now. There's the image that we just built, and there's the node images that are usually installed when you run docker build. So let's try running this image. Let's first make sure the app is not running somewhere else. Refresh, 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 refresh. Okay, it's not running. Okay. So now all I have to do is docker run node bulletin. And that's it. How easy it is, right? But since we exposed a port, we need to tell the command that yes, this is the port that needs to open up for this container. Now there is a small difference between a container and an image, but I don't really want to get into the details of it. But just know that whenever you run a container, you'll have to publish these ports outside the container. So let's run this. And here's the exact same output that we had a minute ago when we were running our application with a pure npm start. And it's running on port 80, so let's see. Refresh, and it works. There it is. There's our application running inside a Docker container, and yeah, it's running right there. Let's see if there's some logging. Yep, it also logs everything that just like it was logging earlier. And there's our application. Let's try interacting with it. Yes, I want to delete this. I want to delete this too. And let's add a Docker intro session here. And let's say tomorrow and submit. Yay, it works. Well, so I think, yeah. Now we can close this and the image stopped running. Let's verify that. Yep. So now this is kind of a weird thing because if you're, or I'll show you. Now I just ran this command. You can also run a container in a detach mode, which now when you do this, it'll just run the container and it'll return back to thermal, so you can use it for more commands. Let's see if that's running here. And yeah, it's running. And this time we don't have logging because it's running in detach mode. It's running in a separate isolation. It's not attached to our terminal. So now we can look at that using docker ps. So I'll need to zoom out, I guess. Come on. Oops. Clear. And the terminal is not cooperating with me. Docker ps, there it is. So the image running is node bulletin, which we just made. These are the published ports. There's some basic information about the running Docker container. There's a name for the container and there's an ID. Now if we want to shut down the container, all we have to do is docker stop, and let's put in the name. Docker stop name, and it's stopped. Now if we do docker ps, there's nothing. And if we go to our web browser, we can see it's not running anymore. So that was a basic demo of how Docker works and how it can be used. Let's get back into the slides. Oops. Give me just one quick minute here. There we go. Okay, so that was the demo. So why do people use Docker? Why are people so crazy about Docker? Let's look into that a bit. First of all, Docker containers are very portable because Docker images are, it's an all-in-one package for your application. Think of it as like a windows.exe file. You can give this image to anyone, and as long as they have Docker installed on their system, they can run this image exactly like we just did using docker run image name. That's it. It takes a single command to install the image from Docker Hub and another single command to run it. And this also means that when you deploy your app to a server, you just have to deploy the Docker image, not all the environments. You don't have to configure the environment. It can run anywhere. Like, it's easy to install and run. Yeah. So scalability is another great benefit because everything is just a container. You can run multiple containers. Docker has this way of, Docker calls it replicas. You can run a single you can run a single container with your app in it. Let's say you have 100 users and you have one container that's working just fine. One day, for some reason, you hit 500 users and your app is now slowing down. You can tell Docker that you need 5 containers, and Docker will run 5 containers with the same image, and they'll all be running parallelly. These are called replicas, like I said, and Docker can even load balance these replicas. So if 500 people are using your app and your servers are getting 500 requests at the same time, Docker will automatically distribute these requests between the 5 containers. So each container only has to handle 100 requests. And that's pretty good. The Docker has a huge ecosystem because it's been around for 7 years now. It has experienced some exponential growth in the past few years, which means anything that you want to do with Docker or you want to do with containers, there's some tool out there that can do it, and you can just use the tool and it works. Another reason, the main reason why Docker is popular, because it's pretty easy to use. We just build an image from our application using a small Docker file with 5 lines and a single command. These are some results from the 2019 Stack Overflow survey. Yeah, you can read it out. I'm not going to read it out loud. And Docker makes collaboration very easy. Like I mentioned before, all you have to do is share your image. And for that, we have Docker Hub, which I've been talking about for too long now without exactly explaining what Docker Hub is. So let's see what Docker Hub is. Oops. There's Docker Hub. Docker Hub is basically like GitHub for Docker images. You can go to repositories and see there. Explore. You can go to Explore and see there's a bunch of different images with a lot of things installed. This Docker image has Oracle database, Java. If you want to run Java, you'd probably start with this image. And this has MySQL in it. There is a plain Ubuntu image. If you want to start from scratch, you can just get this image and do whatever you want. There's a Postgres for running database. There's a Node image that we have been using. And so these are the official images, like you can see here. Now there's a lot of other images that people themselves have put there. And just like this one, this is the one that we just built. And we're going to push it to Docker Hub pretty soon. So time, we already have that. Oh yeah, another demo. Okay. So, okay, Docker images. We just built a Docker image and it's right here. Now we want to share it with other people, or we want to deploy it to a server. How do we do that? So the first thing that you do is you have to sign up for a Docker Hub account, which is free, and create a repository. This is one repository I have created, Node Bulletin. So let's push our image that we just built to this repository. Oops. Right. So there's the image. First thing I have to do is tag it with the name. So just like GitHub, every image name has a username followed by a / and node bulletin. That was the name, right? Yep. Node bulletin. I think there is a T there. And node bulletin, that's the name of the image that I have right now. Okay. Huh. Okay. I think I've forgotten how Docker tag works. Okay. So we don't need the dash T here. Now all we need to do is docker push name of the image. Agrawal09 node bulletin, and that should take care of it. Okay, done. Let's see if that worked. Refresh this and updated a few seconds ago. It was updated 2 days ago right now. So now that this image is on Docker Hub, we can pull this image down anywhere we want. So for that, I have a couple servers here. Okay, yeah. So let's see. There it is. Exit out of this. Clear. So right now, of course, I'm on my local machine. Let's go to a server. Ubuntu. Now this is a server I got from AWS. It has Ubuntu installed in it, and it's in the cloud, basically. So this is kind of how you'll deploy a Docker image. Now, of course, usually this process is automated, but right now I'm doing it manually just to show. Now this is Ubuntu. Let's make sure this is Ubuntu. Yep, apt exists. And do we have Docker here? Yeah, we also have Docker here. So let's pull the image down. Docker pull. The name was /node bulletin. This will pull down the image that we just pushed. And there it is. That was pretty quick. Again, because the base image is node, and node image already existed here for some reason. Docker images, let's see. Yep, there's my image. Now, we run it in the exact same way that we ran it in anywhere else, basically. So docker run name of the image, bulletin, and let's add the ports here, 80, 80. And press enter. That's all we need to do. Now it's running here. Magic happens on port 80. Let's check this out. This was the Ubuntu, so there's the IP address. Let's go to this IP address, and there's our application once again. Oops, you guys can see it. Still getting started with it, sorry. So these are my servers, Ubuntu. There was the public IP. I copied this public IP and pasted it here. Now this is our application running using Docker with 2 commands. Now this was a simple Node.js application. Imagine if this was a bigger application with a lot more dependencies and required a lot more setup, and maybe only works in Linux. Maybe Windows doesn't have all the dependencies and requires even more complicated setup. So this is a pretty good way to make sure that your application will run wherever it's running, because it's running inside a container. It doesn't matter if it's running in a Linux server or in a Windows server or in some Mac development machine. Again, doesn't matter. So let's try switching it off. Control-C. And It's gone. Now we can do the exact same thing with any other operating system. I have another server here which is running CentOS. Clear. And let's see, it's running CentOS. Yeah, it doesn't have apt, it has yum. So CentOS is a Red Hat distribution, but it really doesn't matter because as long as there's Docker here, I can always pull the same image, node bulletin, and I can run the image exactly how I ran it anywhere else. Node bulletin, oops, that's not the name. And there it is. Magic happens on port 80. Now let's call the Ubuntu CentOS. It's CentOS Docker. The public IP address of my cloud machine. There we go. Same application running in a completely different environment, but it doesn't matter because we're using Docker. Isn't it fun? Okay, I think that's mostly what I had. Okay. All right, so that was my second demo. Conclusion. Docker is a container management tool. You can build your code as a container image, and you can run the container image anywhere you want. As simple as that. Here's some resources. There's Docker's official website. There's a getting started tutorial, a quick tutorial on YouTube, and a pretty long, I think it's a 2-hour course on Docker by FreeCodeCamp. There's some tools, Docker Compose, Docker Hub, Kubernetes. These are some words that you'll hear thrown around a lot when talking about Docker. And if you want to know more about what containers are, so there's a link to Docker's take on containers and a link to Red Hat's website that talks about containers, because containers have been around for a long time. I think they've been around since 2002 or something. But Docker was a pretty revolutionary tool. That's all I have. If there's any questions, I'm sticking around here for a bit longer, so throw them in the chat. There's, again, plugs to my LinkedIn, GitHub, Medium, and Slack, so you can chat with me anytime. Unfortunately, there's no clapping on YouTube, so if you're running on Linux, Docker containers can also be given access to your host kernel. That is true. On Linux, you have that control. You can give it. I think they always run on the same kernel. But on Linux, of course, you can access the host kernel if you really want to. For most use cases, you won't need to, but if you really want that, sure, you can do that. Thank you for the clapping, everyone. So if there's no more questions, I'll add a link to the site in the video description. It has all the links, and my demo it's also on GitHub, so I'll add a link to that too. It has the commands are in the README file that you can use to play around with Docker, and installing Docker is also pretty easy. I think I kind of skipped over that. Let me quickly show that. Yeah, Docker desktop. That's the fastest way to containerize your applications on your desktop, basically. Yeah. All right. Thank you, everyone, for attending. Again, sorry, there's no free pizza. Ever use Docker as part of your product? Code runs all of its code. So where I work as a software developer, I think we have two projects running. One of the projects use Docker in production, and the other one, they used to use Docker. I think they ran into some sort of issues. Not Docker related. It's kind of yes, we are using Docker as part of our product. Lead code, I am not sure about that. I know that lead code exists. I've never used lead code for, I think, anything. Yeah. All right. Thank you for attending, everyone. Make sure you vote for the amendment thing. We need as many votes as we can get. And I'll see everyone in the chat on the next meeting.